Hey, everybody. Good morning, good afternoon, good evening, depending on where you are. Welcome to Introducing Particle. My name is Brandon Satram, and this is a new series here on Twitch, and also we'll show recordings later on YouTube, that is designed to sort of introduce our community to the world of Particle, to Particle employees, developers, and customers that are building real IoT solutions. I'm super excited today to do the first episode with someone that many of you know and has been a longtime Particle employee, and that is Mohit Bhoite. And we're going to spend some time today chatting about his experiences at Particle, what it's like to design hardware, and then also his fun times as an increasing Instagram celebrity. Maybe he's not going to want me to call him that, but we'll have some fun talking about his Instagram projects as well. If you are here live on the stream today, and hey, I just saw Dot Kami and Kevin Monk. Hey, awesome. And it's being streamed from the Particle HQ as well. So hey, everybody out there at Particle HQ in San Francisco. We're going to have a good time today. If you're here live in Twitch, feel free, please, to ask questions in the chat. I'll be keeping an eye on chat. I've got a lot of questions ready for Mohit myself, but we're happy to just field anything you have as well. So with that said, let me switch over to the man of the hour, to Mohit. Hey, Mohit, how are you?
Good. Hello. Hello, everyone. Thank you for hosting me, Brandon. This is super exciting. I don't think I have ever done anything like this before, so
awesome.
See how this goes.
Yeah, definitely. Well, it's going to be fun. I have every confidence it's going to be fun. So why don't we start today by just telling us a little bit about yourself, about your background, education, sort of how you got into the world of hardware design, all that good stuff.
Yeah, definitely. I think my story goes in similar fashion where, you grew up, you are a tinkerer, you like to open up things and see what's inside, try to fix things, which is the typical makery thing. But I grew up in Mumbai, India. I went to school to study electronics. After I graduated, I worked at a startup. Back in that time, it was called Robotics Institute, and then after it was called Think Labs. The idea was we used to create these workshops for school kids and university kids, teaching them how to build robots. And then today we call it STEM education. But India, I don't think there was anything called a STEM education. So basically, we designed these workshops, took these robotic kids all across India and taught these 2-day seminars, workshops to kids to how to build robots, learn C programming, stuff like that. And I did that for 2 years, and I thought maybe it was time to do something more. So I applied to universities in the US, got in, and then basically finished my master's in robotics from UPenn. That was a fun time. And then briefly, I worked at a robotics startup that tanked. And so after that, I met Zach and Zach, joined Particle, and then rest is history.
Yeah, definitely. So that was actually going to be my next question. You've got a pretty diverse background, and it's cool that you're at a robotics startup before joining Particle. So you have had some experience at what it's like to try to build end devices or consumer devices using the embedded hardware of the day. But how actually did you meet Zach and Doc and come to join Particle? And how long ago was that?
That was over 5.5 years ago. I think that was, quite a while. And I think Zach, Stephanie, and Will were the 4 full-time Particle, or rather Spark people back in the day.
Spark at the time, yeah.
Spark devices, to be precise. So I met Spark through AngelList. One of my previous work colleagues said, hey, there's this cool little startup in Minneapolis. They just closed their Kickstarter campaign successfully. You should go talk to them. And I reached out to Zach and Zach, met with them for an hour. It was love at first sight. And I was hired within that week. And so it was awesome. I think at that time we had one electrical engineer who was a contractor. So I was hired as a first full-time double E on the team.
First full-time double E. And employee number 5, if I got my math right.
Yes. Yep.
Nice.
That is
okay. Cool. 5.5 years ago. That's crazy to think. And Particle, I do believe, I think I saw this on our Slack late last year. I mean, we sort of formally celebrated our 7-year anniversary just late last year,
Yeah,
which is crazy. It's crazy to think from the Spark Devices days to now Particle.
I know. And
Um,
Spark wasn't even doing what we do today. I think Zach at that time was building internet connected light bulbs.
That's right, and I don't. Maybe not everybody knows that story. I know a lot of longtime Particle developers, and I just joined the company just over a year ago, but I was a Particle customer for about 3 years before that, and I think even I wasn't aware of the story of how Particle started and sort of grew out of the former Kickstarter campaign. So what can you actually share about that story a little bit of your
I,
experiences with?
yeah, I can give you extremely brief. I think that question would better be answered by Zach himself. But
Sure.
yeah, it was a Spark socket, which was a light bulb that was connected to the internet through Wi-Fi. And then I think Zach decided to pivot away from the idea, and instead of focusing on just one product that is connected, he wanted to open up the world of internet connected devices as a dev kit rather than just one product. Out of which the Spark Core was born, and then they were able to raise like little over $500,000. They had recently graduated from the Hacks hardware accelerator from Shenzhen. They were back in the US. Will was still in China. I think he was there for a long time. But yeah, we had a little co-working space, and we were, basically when I joined in, we were working on fulfilling the Kickstarter campaign, which
Okay. Okay.
was Spark Core.
So you're in the throes of delivering those dev kits, delivering the Spark cores to all of the very eager backers.
Hmm.
Because I like to tell people when I talk about Particle and a bit of our history, and I had an outsider's perspective back then, but the state of the art in those days was if you were trying to build something that was Wi-Fi connected, you were, the state of the art was you would buy an Arduino Uno probably, or one of those kinds of devices that was around 35, $40 at the time, and then a $60 to $65 Wi-Fi or Ethernet shield. So you were in $100+ just to get something connected to the internet, to some sort of embedded project, unless you wanted to roll your own, of course. And when the core came along, I mean, what, it was around 40, 35, $40 in the campaign, in the Kickstarter campaign days. And that was a vastly less expensive option for actually getting something on Wi-Fi, which I can see why it was so appealing for a lot of developers, myself included.
Right, and it wasn't just the hardware itself. You got end-to-end connectivity with it. It wasn't just you were buying the Spark Core. You're getting all the connectivity with it, so, which was, I think, instrumental in making the Spark Core so successful.
Yeah, yeah, definitely. So we had one, there's a question in the chat so far from JR Steelhops, and thank you for the follow, by the way, JR Steelhops. And I saw another one that I missed that came along with thank you for the follow as well. You asked, are we in the same room? We are not, actually. We are. Mohit is in Minnesota, where he said that it's supposed to snow 4 inches today. And I am in Austin, Texas, where it's 50 degrees outside, and I just went for a run this morning. So that's pretty fantastic. Yes, we are in different rooms and have our own sort of workshop setups. Mohit has a pretty awesome workshop setup behind him. We'll spend a little bit of time talking about that in a bit. But I wanted to get back to your early days at Particle. You joined within a week of meeting Zach and Zach. And what was your first project at Particle? So what's the first thing that Zach and Zach, excuse me, asked you to do?
Oh man, that was a long time ago. I think my first project, at least from what I remember, there were two things happening simultaneously. One was, making sure the Spark Core was reviewed and ready for production. But more importantly, I was assigned to design the hardware that would test these Spark Cores as they came out of the assembly line.
Oh,
So basically designing the hardware part of the testing infrastructure, which was pretty cool. Nobody on the team had done that. I myself had never done that, and it was exciting. Like
and
new,
that is
everything was new.
And that's a fascinating piece of the process because I think when it comes to hardware design, like that is I think most people, myself included, I mean, I'm a former web developer, self-taught maker, tinker in a lot of ways. I never thought about the hardware testing and verification sides of things, creating test jigs and actually verifying hardware connections and those kinds of things. So what does that mean? What does that verification process mean and look like?
Right. I think, yeah, like you said, people often underestimate how much effort needs to be put in testing infrastructure. Sometimes it's even more complicated than the actual product itself. So things that you're going to try and do, especially with a connected product, is make sure all the hardware bits work. All the GPIOs work, all the lights, buttons, the hardware part of it, and also then make sure the firmware that is burnt onto the device is able to talk to the cloud, set up all the credentials, get that into the database. Basically, everything that now gets out in the world is on its own. And so making sure both the hardware and software are tested is important.
Right.
Unlike software, you can't just send a patch. With hardware,
Right.
you physically modify the device if something's wrong. And so it's pretty important part of the step.
Right. That was a painful process, or a painful learning lesson for me when I designed my first custom PCBs, was learning that lesson of, oh, I completely misrouted that. I made a mistake and now I have to do another spin of the boards and wait for another order to come in. So I can't, and that's just doing personal projects. So I can't imagine at scale how you have to be very, very precise and careful not to let those sorts of problems make their way out into the wild in consumer products.
Right. And I think at that time, since this was a connected product, being able to talk to the test jig all the way from the United States to China, behind the firewall of China, it was intense. And I think at that time, David and Will were the people who were working on the test jigs. They were literally spending like nights at the factory, talking to these test jigs. So I think first learning experience were pretty hard.
And so this is Will Hart and David Middlecamp, who are still with the company, other longtime Particle employees, and they were actually in China during this time, actually in Shenzhen, working with our contract manufacturer, doing a lot of the verification as you were working on the design pieces of this process.
Right, right. Yeah, and yeah, the time difference, the language barriers, cultural barriers, we were taking on a lot. I think we were only 7 people at that time.
Oh wow. Yeah, so that's quite a monumental effort.
Mm-hmm.
Cool. Okay. So that was actually does lead me into my next question about sort of what the early days of Particle were like, because the company has been around for 7 years, but in many ways has grown relatively slowly over that first time, carefully, as we went from the core to the photon and then the electron. And then really over the last couple of years has grown quite a bit as more people have joined the company. But how would you describe sort of the early days at Particle and what it was like to move from the core and a very Kickstarter centric sort of company into adding additional offerings with cellular and the electron, and what were those early years like?
Yeah, sure. I can talk about the very first day at work. Showed up to this beautiful, beautiful co-working space in downtown Minneapolis called COCO. Now they are called Fuel Collective. But back in the day, we had this campsite, which was literally, I think, 3 desks and surrounded by whiteboards. And I walked in, sat next to Zach, and that was it. Like it was Zach, Stephanie, and myself. Well, Will was in China. And I still remember like the first Spark cores, like the actual physical devices for the beta testers were hand populated by Zach himself. Now imagine Zach does not have a background in electrical engineering, but he knew things well enough to like populate and design and test these. And he was more than happy to just like hand it over to me. Like, okay, you take, and I'll go do the CEO things. But yes, being a small company in a hardware landscape is extremely tough. Especially we were working with the TI's Wi-Fi chipset, and for a small company to get any kind of tech support, it's extremely difficult with limited funds and resources. So that was hard. But on the other side, being open source helped us a lot. I still remember the time when we were designing and we open sourced the schematic for the Spark core. And Lady Ada from Adafruit reached out and said, hey, do you know there's a hardware bug on this chip? You need to fix it. and
Wow.
fixed it. And imagine, like, if we had not caught that, I think we would have been in big trouble. For a small company, that would be, uh, yeah. So being open sourced helped a lot in the beginning. Our forums, people were just like so helpful all throughout. Because
Hmm.
even though we were 7 people, we had the resources of, I don't know, at least 100 or 200 people who were extremely active in the community back then. So yeah, going from that and then slowly acquiring expertise in different domain when it comes to cloud infrastructure, marketing, uh, production. I think the China team at that time was non-existent. Building up the China team was a huge uh, change for us, because now having full-time employees in China gave access to the local knowledge, contract manufacturers, having somebody physically be there in the factory to make sure things are properly made was very important. Um, so yeah, so after I think the Spark core wasn't perfect. There were some inherent firmware bugs that we had to take care of, and we couldn't just wait to have an improved version of the Spark core brought into the market. And so
Right.
that's how Photon was born. It was again crowdfunded, um, not Kickstarter, but internally crowdfunded. That was successful. So after, to try and add more radios to the portfolio, we decided to focus on cellular, which was
Hmm.
again uncharted territory, even more so than Wi-Fi, because it was very easy for you to, just like cobble up like a Wi-Fi shield and put it on an Arduino and get something working. Uh, but for cellular, things were expensive. I think it was like SIM 900 was a module that you could buy and talk to, send SMSs. But there was again no such thing as IoT using cellular devices. So
Right.
that process was again pretty intense. Again, going through the uncharted territory of talking to MVNOs and cellular operators. Certifications was a big pain in the bee. And then I think by that time we had gotten good at designing and developing and manufacturing and uh, selling hardware and software.
Yeah. So we had a great question from chat. This is from Dread Warrior 73. Have you experienced limitations around being located in Minneapolis as opposed to being somewhere more tech centric, such as Silicon Valley? And there's two parts to this question. One is, I suppose, the particle question in general. So maybe you can share, because maybe this is something not everybody knows, but Particle, even though we started in Minneapolis, did actually move headquarters to Silicon Valley, to San Francisco a few years ago. But you're still personally located in Minneapolis. We have a large team that's in Minneapolis. We also have a lot of people that are remote around the world. So can you share a bit about what it was like for the company to sort of move from Minneapolis to San Francisco, and then what it's been like for you to remain in Minneapolis and be working not only with folks in SF, but also a team in China that's now 16 hours away, and all those kinds of things?
Yeah, oh yeah, we completely forgot about the transition. So I think a year and a half into Particle, I think the founders made a tough decision to physically move the offices, the headquarters to San Francisco, because that's where the investors were, that's where all the help and support they were getting was coming from. It wasn't easy. I think most of the team back then decided to stay back, uh, given how expensive San Francisco was, and that we were just still a tiny startup. Uh, and so I think there was some friction in communication and the time zone, but at the end, we all embraced the whole remote working culture. And I think now it's in the very DNA of how Particle operates, and why it's successful is because hiring talent where it's available and where it's happy, I think you just get more out of it. And
Yeah.
so, yeah, Zach was literally running Spark at that time from his home in San Francisco, just because we hadn't had an office. And then we started hiring people wherever they were available. It wasn't, only about San Francisco or about Minneapolis. Um, so, yeah, and now, like you said, we have a team around the world,
Hmm.
uh, and most of the engineers are remote.
And with that around the world team, you mentioned a few minutes ago about having the team in China and sort of the evolution of the process of early employees like Will and David spending a lot of time in Shenzhen. Now we actually have a team that's based in Shenzhen. That team came from an acquisition of Red Bear, which is a product that made a company that made a lot of modules or compounds that worked well with the particle ecosystem even before that. Phenomenal team of some amazing engineers. And so talk a little bit about what that's been like to not only get to know that team more, but just that backstop of having such a talented team of folks that are focused on the hardware and what that's enabled Particle to do.
Yeah. Yes. So even before we acquired Red Bear, we had a team in China. I think there were 4 employees, if I'm not mistaken, who were still working remotely. We had a contract manufacturer, like a production manager, an engineer, a marketing person. And so we did have a team, but it wasn't in one office. They were still spread across the Shenzhen region. And that was instrumental in just having people in China, the locals, and knowing how to operate that landscape. And it was working very well. But as the team grew at Particle, it became apparent that we would need to grow the team in China if we were to, scale up our production. And the timing was just right, where Red Bear, was already working with us, and making them part of our team just like automatically doubled the size of the China team. It's funny because then we had, I think, 2 electrical engineers full time in the US back then, and nobody, was in China. I think there was one person. But after the acquisition, I was having a hard time, like, how am I going to, work with a team all the way in China, getting across the language and time zone barriers. But I don't know, knock on wood, it was amazing. Like the team, Red Bear team was already so well bonded and knew Particle inside and out, and just like extremely good people to work with. And I think it was, I don't know, it was kind of a jackpot.
Oh yeah,
being able to work with people who you got along with just fine.
And how has that changed your design process over the course of the last several years? So in the early days when you were handed the initial designs and you were responsible for doing most of the schematic design and layout for the early boards versus what we did with our 3rd generation of hardware, the Argon, the Boron, and the Xenon, and in addition to our upcoming system on module versions of those boards, what's changed in terms of what you've done day to day to work on the hardware design process?
So in the beginning, as a double E on the team, I had to do everything: designing, review, submission of the PCB, to getting it populated, hand assembled, tested, like end to end. Eric, who is a electrical engineer in China, was helping me out with this. I think without somebody there, it's impossible. It's like ordering PCB samples online, getting them here, not knowing if they will work, if they are to spec. But yes, having to do everything now versus not having to do everything. Now the risk is more spread among the team, and also things are moving at much faster pace because of it. You can get design PCBs, get them hand populated, tested, verified. We have now individuals who do have been assigned specific tasks throughout these steps. And having more eyeballs look at your design and verify and learn from each other is like extremely helpful.
As it just made me think, as someone who has a background in software, I think we software developers sort of take for granted how a lot of times when we do work in companies, there are teams of software engineers, there are teams of folks that work together. But a lot of times what I've learned over the last couple of years is the double E's in many cases, unless you're at large companies, tend to kind of work in smaller teams. They tend to either work solo in a lot of cases, or they work on super small teams. And so I think we're quite fortunate, as you say, to get to that point where we have a growing number of double E's that are able to sort of take those component pieces of a project and really not only have that checking of each other's work, but to add their expertise to the assembly of new hardware, which I think is what has gotten us to this place where we're able to design more complex types of hardware, like we've done with the new third gen hardware, as well as the SOMs, right?
Right. Definitely. And I think designing in the US is one thing, but getting it manufactured in China is different. Because we are so accustomed to like looking up DigiKey for parts,
Yeah,
um, then selecting parts based on the availability there. But there's a whole new SKU of parts that are available locally in China that are just as good, and you never get to see it, know it. And so being able to compare notes and say like, oh, we are using this part versus that part, and so it's the whole design process is extremely efficient and different now.
that's really valuable. Cool. So we got another question from Action Jackson 113. Huge fan of the channel. Thank you so much. What parts did Eric get involved with and when he joined the team? So you mentioned Eric as one of our double E's in China. Was it reviews, sourcing, other parts of the hardware design? So when he joined, what were some of the things that he was most instrumental in helping with early on?
He was kind of doing everything, making sure, like he was the point of contact in China, like a point of contact engineer in China, who was making sure that the designs that we were ordering were getting placed, like acting as a production engineer, a project manager, and electrical engineer. Yes, so we were going back and forth between design reviews, getting the PCBs made, shipped, so logistics, talking to the factory about testing, production yield. He was doing everything, I would say.
Crazy. Yeah. So that's cool. So as we get a bigger team and we can create more complex pieces of hardware, as any company does, that makes certain things easier, but I'm assuming that probably also makes things kind of tricky. So one of the questions that I had for you, tricky in terms of the scale, when we take on more complexity, that can have its own challenges. So what's the trickiest piece of hardware that you've ever had to design?
Oh, every single time we take on a new flagship product, it's more complicated than the previous one. But I think to date,
Yeah.
most complicated, trickiest part would be where I learned a lot was the boron,
Okay.
which is the LT cellular version of the mesh product line.
Yeah.
Like having it like an 8-layer design with buried vias, like extremely dense, and then working with multiple radios, which means multiple certifications.
Yeah.
It was a beast. But at the same time, we had a bigger team to have a crack at it. Having said that, I think we are still struggling to, how in software, it's easier to collaborate on a piece of code. So you can come in, do your edit, and, share those commits with your fellow engineers and they will review it. Unlike that, in hardware, if you're designing a PCB, it's extremely difficult, like on a small piece of PCB, to have collaborators.
Right.
That piece is still a little tricky. So there needs to be a main owner, and that's how we are doing it, like a main project lead, and then you have peer reviews of that product, and that's how we are operating now. But it would be interesting to see as we scale how that would grow. Like how will people collaborate when it comes to designing circuit boards?
So is does the complexity inherent in just that it's tough to view differences? Is it because of the tools? So for instance, we use Eagle as the CAD tool for designing PCBs at Particle. Is it not necessarily a limitation in Eagle, but in any CAD tool, is it because you're working with a visual medium as opposed to text and code? Is that what makes it harder to collaborate?
Correct.
Yeah. So what are some of the ways, how does that manifest in terms of and you mentioned the boron as the 8-layer board. So for folks that may be relatively new to hardware design, typically when you design a simple PCB, it may be a one layer, 2-layer PCB is relatively common. You can have copper traces on the front or the back that allows you to actually lay down connections between electrical components on the board. An 8-layer PCB means that what's on something that's not that much thicker than a 2-layer PCB, you have actual eight layers of copper that are then routed to one another so that you can fit a very complex design on a relatively small package. Which means that you are in a visual tool zooming in and squinting and trying to sort of make sense of all of the various layers as they work together. So given that understanding, or that bit of background, how does that manifest in terms of how you collaborate with an Eric or with somebody else on the team?
After Redbird joined Particle, we had a very experienced engineer come join our team. His name is Peng, and he had vast experience designing complicated circuit boards in China. And so he was using a different tool to design it, but then he had to transition onto Eagle, and so he brought in his perspective, like his way of designing complicated circuit boards. Commercial products. And so I got to basically learn a lot from him when it comes to design practices, design for manufacturability, which is, again, a beast of a topic in its own, as to designing one thing that can be, made one time, but how do you make something that is, repeatable in mass production? So yeah, when it comes to complicated design, I think the time zone actually helps, where I end the day with the design and then bring it up for review, and then they start their day, they look at the design, and make changes or suggest changes, and then the next day I get back at it. So it's actually sometimes it's advantageous to have the time difference where we are working nonstop and the reviews are happening and you're making changes, but everything is happening online. We use GitHub for both our code and hardware design files. They're all open source. And so, yeah, basically.
So how do you then, so when it comes to using GitHub, it's fantastic. And for folks that are, and I'll throw this in the chat, but all of our hardware designs, Mohit mentioned, are open sourced out in our GitHub repo, particle-IoT. I will share that. There's a lot of great stuff out there from over the years. But when you're using GitHub to iterate on a new design, something that hasn't yet been produced, and you're working during the day, you have other parts of the team that are working, you're syncing on chat. What does that look like in terms of changes? How do you see those changes? Are you communicating mostly over text, like I changed this part, changed this layout? Are you actually looking at the text equivalent of the schematics and the board files in GitHub? I mean, what does it look like to view the diffs from one day's worth of changes? I asked this as a software developer. I know I can look at text, I can see the change, but what does a diff for a PCB look like?
Yeah, I think I wish there was a GitHub equivalent for CAD. There's no way of looking at diffs, at least for Eagle file formats. So basically, I either have to compare visually between the two PCBs, or like we do is we explain what was changed, and so that you drive the attention to the changes, and so that person can focus on those changes. But yes, I'll commit the changes. Team in China, will look at it and see, and we mostly communicate over Slack. Sometimes we use the GitHub issues to keep track of all the changes, and so it's kind of all over the place when it comes to how we communicate.
Sure.
I think right now the most efficient way has been through Slack, and just detailing out the changes, the reviews, and as I said before, each person is taking a lead on particular product, so he or she is taking the lead and then is asking for peer reviews. So one person is always in control of the design while others are providing. So it goes back and forth.
Yeah. And, frankly, there's something to be said for using Slack as the visual way to call attention for, I changed these things, I noticed these issues. It does force you to be explicit about why you made changes and why you may think that a certain part needs to be swapped, or why a route needs to change, or why there could be a potential RF issue, something along those lines. It is good, rather than just making a change and assuming the other person sort of knows your intent, to have to communicate intent is valuable. So I can see that actually, even though it takes time, it does make the design process much more explicit, which helps in a place where when you're at a distance, over communication by default is a good attitude, good approach to take, right?
Definitely. Yep.
So I got a question from DC Shelt. This is a good one. So thank you for this, David. What are your tips, Mohit, for those looking to get into electrical engineering and hardware design?
Oh, man, I get that a lot actually.
Yeah.
There's no basically all you have to remember is there's no quick uh, how to say, you don't become instantly good at electrical engineering.
Hmm.
Even if you study in books, it doesn't help. You have to be always constantly be building things and failing. Um, and so, unlike software, where you need just a piece of computer to write your software, in electrical engineering, you need to have all the right tools to building and designing. So yeah, long story short, just keep building projects and learning that way rather than relying on, I don't know, work or your university or class projects. And I wish there was a time when the Bell Laboratories would have like PhDs and Nobel laureates taking on apprentice and basically teaching the new generation about physics and math, electronics. We don't have that anymore, especially in the startup culture where everything is moving so fast. You have to be learning on your own constantly.
Yeah.
Um, and in small teams, it gets difficult not to have mentors. And so this is a complete segue to what I was going to talk about. But I think at
Perfect.
Party
Yeah.
we also encourage you to seek out mentors outside of your job. And so I have a mentor here in Minneapolis, Andy Warner, who has been with us, ever since Particle was Spark. And so getting people who have, tremendous years of experience and, talking to them about hardware development and electrical engineering also helps, in addition to just doing things on your own.
Yeah. And when it comes to doing things on your own, I think that's great advice, and finding things that you're passionate about and interested in, right? So picking a vehicle, a problem that you'd like to solve that can be best solved by designing something for yourself. Even if there's something else out there like it, try
Right.
to
And
build your own, you
yeah,
know?
it has never been this easy to get into electronics. Like, it's so, I mean, yeah, I don't even know where to start. Is Arduino changed a lot. Amazon changed a lot. Having access to parts easily, quickly, cheaply changed a lot. So you don't even have to have a formal education in electrical engineering to build things anymore. Uh,
Absolutely.
so I think, yeah, you pick up a problem and even if you don't have a problem, you just pick up a project that seems interesting and start building it.
Hmm. And one of the things that I love about Particle, and this is a bit of a shameless plug moment, but I was one of these people. I've said a few times already that I'm a, software developer by background, self-taught. I was one of those people that looked at this world of EE and physical computing and IoT and thought, I want to do that. Like I've pushed around bits. Now I want to push around atoms and do something real, build something, design something. And I think that one of the things that drew me to Particle, not only the inexpensive nature of devices like the core and then the photon, but was also the fact that I think the entire company and platform is built around this idea of making IoT development accessible for people that may not already have that double E background. And so I think that that's a really cool perspective to just build and do and then find tools that help. Like you said, it's never been easier because of the Adafruits and because of the DigiKeys and because of great resources out there. I will again shamelessly say because of Particle as well. I can say that from my pre employee experience, but those types of platforms do make it easier to where really anyone can get into this, and it's pretty exciting. So oh yeah, and Action Jackson said possibly getting started hacking together a bunch of drones, noting the large number that you have there. And so that actually does help me segue, because I wanted to spend the last little bit of the interview here talking about your personal projects, because you do this kind of stuff. You do this because you love it, so it's something you do as your day job. But you also have an aspect of your life, your personal life that's focused on electronics and the kinds of things that you build for fun. And so, what kind of work do you like to do in your free time?
Oh man, So as much as I love working at Particle and building products at Particle, anytime you are working on work projects, you're pretty limited as to what you can do because the specifications are tight, the goals are tight, the timelines are tight. So being able to look outside and take on projects that you do just for fun is always nice. Often feel stagnated if I'm not building physical things with my physical, tangible things. And so, you know, I've been like going through life just collecting skills, like, learning how to design 3D models, 3D printing, machining, CNC, flying drones. I just have to keep on doing that. Otherwise, I get extremely bored. And so I call these micro obsessions where I'm like, drones, super cool. I need to learn how to build one. And then I do it, fly them, and I'm like, oh, okay, they can, be put back on the wall again.
Right,
So,
right.
knowing my background is robotics, I've always been interested in, things that move, things that can be programmed, are mechanical, kinematic. And so I just often dabble whatever catches my eye. So drone was one phase, I would call it, especially the FPV flying, like micro drones. I still
Oh,
do
yeah.
it, but Minnesota doesn't allow you to fly drones outside all year round. Uh,
Okay.
so the mini, they call them, what are those called? I'm spacing out here. Anyway, tiny micro drones with tiny little cameras that
Oh,
you
the tiny
wear.
whoops?
Tiny
Tiny
whoops,
whoop?
yeah,
Yeah, yeah,
tiny
okay.
whoops. Those were fun to get into just because then you can fly them indoors, even if it's cold outside.
Nice.
And drone community has like taken off completely, where they are using like really, really tiny MEMS sensors and fancy microcontrollers to build these flight controllers.
Hmm.
So that was fun. Then just having access to a 3D printer at home just opens up so many doors of possibilities. It's not just about printing sculptures or uh, static objects. You can actually be building robots, and there are so many open source projects out there that you can learn from and modify. That it's basically I just don't have enough time in the day
Oh,
to be
yeah.
taking on projects.
Yeah, definitely. So before we dig deeper into the personal sides and Instagram, and I have a question about that, I did want to go back. There was a question from Ari Yanate. So tagging along to a few questions ago, what is your opinion on being a jack of all trades, EE, versus a master of one, like RF engineering or some specialization? What are your thoughts on that?
I think it's a personal preference.
Hmm.
I think, especially when we talk about RF, we do need engineers who are RF experts. We also need engineers who know a little bit of everything. So for a company to grow, you need all kinds of people and skills. But on a personal level, I like to dabble in a lot of things.
Hmm.
That does not allow me to go deep into one topic. Maybe through the course of my life, I'll have enough time to dig deeper in every possibility. But I think I take joy out of having being able to do a lot of things at the same time. And to
Yeah.
me, the end goal is not to get good at one particular thing, but being able to get all these skills and use them to build something
Yeah,
more.
yeah, definitely. Well, and I would almost generalize that even more. I think that when it comes to EE, you could make the argument that being a generalist is valuable because it allows you to direct your interest. And yeah, it's definitely personal preference. But I think in the world of IoT, it seems to me that I think there's an increasing need for people that can cross the bridge of hardware and software in a lot of cases where you don't necessarily need to be the super double E expert. You don't necessarily need to be the super specialized web developer, but you may need to be someone that can design a board, write firmware, and build a web or mobile application, or at least through a prototyping stage. And there are companies where that's an exception or that's not the rule because you have more people. But for a lot of organizations exploring IoT, exploring the space, I definitely see a lot of people that are being asked to do all of it, which is kind of fun because it gives you a chance to try to do something new. And as someone who I've always classified myself as a bit of a generalist, mainly because I've never was a very good developer, so I had to have other skills. It's I think it's very useful to be willing to pick up those other pieces as your interests take you there, or even as your company's needs take you there as well.
Right. And I think all of this stems from what you want to be doing. I
Yeah,
think even though my background is electrical engineering, I didn't grow up to become an electrical engineer. The electrical engineering was just one thing that I could learn and which would allow me to, get better at building things. Uh,
sure.
so
Yeah,
I think my degree, if it were a degree, would be like a degree in making,
you're
learning
right.
to make things.
Right, and that should be a degree, right?
Yeah.
So this a great question from Some Disassembly Required. By the way, love the name Some Disassembly Required. That's a great Twitch handle. So a comment was Mohit, love all the sculptures you post on Instagram. Do you work on any? You work at any maker spaces, or do you have all your CNC printing tools at home? So while you answer that, I'm actually going to switch to desktop mode here so I can show off your Instagram account to people. But yeah, so what's your thoughts?
Um, Ever since I was making things, I always wanted to have my own studio, a little space. I think I was influenced by the cartoon called Dexter's Laboratory. Like he had
Oh
this
yeah, yeah.
lab in the basement, and I have always fantasized about having something like that. And there are community spaces here in Minneapolis, maker spaces, but I just like the idea of having my own studio where I can just like work at any time of the day or night and do things. So I've been slowly over the years have been collecting things. So we have, thanks to Bantam Tools, they sent me this. They're titled to desktop CNC. I have a
Amazing.
Prusa CNC, a Prusa 3D printer. I do have access to a makerspace that has a laser cutter. That would be,
Hmm.
the next thing to acquire. Then, the standard soldering station, double E measuring and testing tools. So just like what Brandon has in his background is a tiny little makerspace, I have created one at home. And I feel privileged enough to have enough resources and space to set this up. So fortunately, I do, have gotten to the point where I can, have a makerspace at home.
Yeah.
That is where I spend most of my, not if not all of my time building things.
It's not, yeah, not Dexter's lab. It's Mohit's lab. I love it. And now I have images of that, yeah, the little cartoon kid, and you seeing that and be like, I gotta have that same thing. That's awesome. I feel like I had a very similar aspiration. Like I have built my space over the last 5 or 6 years. It's been a very, one piece at a time, one component at a time. Talk my wife into buying me a 3D printer for Christmas a few years ago. Those kinds of things, like you get there bit by bit. But it's cool that you're able to feed your passions that way. I
Right.
I want to go to the Instagram thing because I think this is interesting. You mentioned a few minutes ago that you know, you had there are constraints in any day job, and so part of what you do to sort of unwind is to also pursue those things that you love, to take those micro hobbies you said and jump in to each of those as the interest takes you there. So how did you go from that to then saying now I'm going to start sharing these things on social media? Because a lot of people will go and do that, but you made the decision. I think what it was early last year, maybe the year before, to start just posting these things and talking about them and using what I will say is some pretty nice photography skills. I will say, sir, to start sharing those things on Instagram. What triggered that for you?
Um, I mean, I have always wanted like a platform to able to share my experiences and the things I built. So I had a website for a long time that I used to, it's sparsely populated, but I would have, projects and blog posts written, but I couldn't find a medium where I would, which was easy enough to share what I was doing.
Hmm.
So when Instagram came along, I was like, perfect. Even though it's a square picture, I can start sharing things. And it's the accumulation of like the different uh, things that I like to do. Is photography is one, especially macro photography. And so, combining my interest in photography with building things and being able to, take good pictures and post them because presentation is key.
Hmm.
Uh, so that started a few years ago, and what just not was wasn't last year, but throughout these, years of building things, I couldn't really find one particular thing I could call mine, and that people would be, people would associate that with me. And that's what I found, I think, last year is building these brass sculptures, circuit sculptures, which I think took off. My goal last year was to become an Instagram influencer, not because I wanted free things.
Yeah.
And I was like, okay, maybe if I start posting, things that I build on a day-to-day basis, people might find that interesting. And so I started doing that. I was at, I think, 1,000 followers at the beginning of January last year. My goal was to get to 10,000 by December, which is, pretty achievable if you are, constantly building and doing things and taking pictures. And somehow through August, when I started posting more pictures of these sculptures, it took off. And instead of 10, it went all the way up to 50,000. I'm like,
Yeah.
oh, this is a real thing. I could be doing this. And so, yeah, that's where I'm at.
Which is amazing. Yeah. I mean, 50,000 and you have, I mean, great engagement. And I think I want to come back to the air wire sculptures or the freeform sculptures, because I think you're right. This is one of the things that has really, really captured a lot of people's excitement, taking things out of a breadboard, not designing a PCB, but actually just creating a sculpture that itself not only allows a circuit to function, but shows off something very aesthetic and clean. And so explain to me a bit about what these air wire sculptures are, and then, how that really has captured your interest.
Definitely. So yeah, air wire sculptures or freeform circuits is nothing new. People have been doing it, ever since electronics was invented. And sometimes they were done for purely because there was no other way to do it. And then there was, there were people who were doing it for artistic reasons. I got into freeform soldering back in 1998 when I learned about beam robotics. This was like a philosophy of building robots, biology, electronics, aesthetics, mechanics, and the founder being Mark Tilden. And he made these amazing, beautiful freeform robots out of broken, CD players and Walkman cassette players. And I don't think he was trying to pursue an artistic expression of using freeform circuits, but he was like, okay, we have these broken things, we can actually put these together and make these seemingly intelligent robots. So that's how I got into soldering and robotics and just like electrical engineering in general. And then I've also seen people do in the art world, like Peter Vogel is another artist who passed away recently, but his work was phenomenal where he was making these interactive sound sculptures. And so combining these ideas of, me loving to build things, having a background in beam robotics and knowing how to do freeform, I was at Ace Hardware one day where I saw these brass rods and I thought they'll be pretty cool for making jewelry. And as I was soldering them, I realized maybe I could be using them to make sculptures to carry electrical current instead of just, being passive.
So cool.
Things. And I posted one thing, I think in 2015, which was picked up by Hackaday. And then I didn't do anything after that. I was just mostly focusing on work and, doing other bits and pieces. So last year I took that, took it back up again. And then Hackaday picked up again. They had an amazing freeform sculpture contest that many participated. So I think this form of building circuits and sculptures is like now trending, people know about it, and so people are doing it, and so that's amazing to be part of a community where they're churning these out.
Yeah, I think I saw that Alex Glow from Hackster had created some freeform earrings, LED earrings. So back to the jewelry thing, yeah,
and
that as well.
One of the sculptures, like the Valentine blooming lily, really took off.
Oh wow!
I think when he made it, I think they had more than like 2 million views on Twitter.
Wow!
So I think the whole like idea of making freeform sculpture is coming back.
That's great. And I love that you emphasize the art side of engineering, because it is something that when I first got into making, I also have a Bantam Tools CNC mill it still has the other mill label on it. So before they did the rebrand, but I have one of those. It's in my garage because it's way too loud to have here in my office. I have a 3D printer as well. And I remember in the early days of when I started 3D printing thinking the sounds that the 3D printer made when it made XYZ changes sounded very musical. Anytime you get into this space of engineering, I think you find these ancillary places your mind goes around. This feels like art. This sounds like art. This looks like art. And it's really cool that you've embraced that, because I think that drives and motivates a lot of us. We're doing something that is useful. It has, but also something that has meaning and allows us to pursue something that's fundamentally creative as well, which is cool.
Yeah, and it's tricky because you go through the school of thought of engineering where you are taught to do things efficiently, the right. And I had to unlearn a lot of those things when you're building sculptures. None of my sculptures pass FCC certifications.
Right.
They're all like radiating antennas. So you have to tell yourself, I'm not doing this because this is the right way to do it. I'm doing this because I'm enjoying the process of building it, and purely for artistic reasons, and not, doing it the right way.
Yeah, it's really cool. .Commie had a question, great question, and I think this is one that many of us have wondered as we've scrolled through your Instagram account. So what camera photography setup do you use?
I have I can show you. This is like a Rebel Canon T4i.
Yeah.
With a 100mm macro lens and a tripod.
Nice.
It's like nothing special. I bought this camera a very long time ago. I think the prime lens is what does the trick, and the lights. And I've just, have gotten better at understanding how the lights work, how the focus work, and by just taking a lot of pictures and setting it in a different environment helps a lot. I think a lot of us are just, especially with Instagram, you just point your camera to a thing, you click a picture, and you post it. But that's not the only way you can share pictures. You can actually have a very decent camera, use Photoshop to color correct things, edit, and then post it. And that reaches people more than just a point and shoot.
So do you have a separate light setup as well? Do you use a light box? Do you have what's your situation there?
Yeah, I just have makeshift table lights that I replace the filament bulbs with white LED bulbs, and I don't have a light box per se, but I do have multiple lights.
Cool. Yeah, I think that is definitely a big part of what makes the difference. Those little details around lighting, and then, like you said, editing in Photoshop and things like that, which is really cool. So we are just about out of time. We have 2 minutes left, and so I'm going to ask you a question that I will likely start asking every guest as we go through this series. So this is going to be my canned end of the interview question. Particle likes to talk about, we like to use this phrase, real IoT. We're all aware that the Internet of Things, this phrase has been criticized, is bandied about. It's on Gartner hype cycles in various places of disillusionment among consumers and whatnot. But we love to talk about this concept that a lot of our customers will focus on solving real problems with IoT. So when you hear the phrase real IoT, what does that make you think of?
I'll backtrack a little bit about IoT itself. I think when we started, Zach didn't even like the word IoT. It was the buzzword we were trying to avoid, because we were trying to figure out how to solve real world problems without getting caught in the whole IoT wave. And I think, but we just had to give in. Okay, this is how people identify things that are connected to the internet. Then we will call it the Internet of Things. Mm-hmm. But the focus has always been on solving industry problems, or solving specific problems where an internet-connected device could come and help. And so when I hear about real IoT is not about remote controlling things. Real IoT is about using the connectivity in your products to solve real-world problems. Not just because it's trending, but because it's actually solving real problems.
That's great. Thank you for that perspective. And again, Mohit, thank you so much for taking some time to chat with me today. Thanks everyone in chat for your great questions, for sticking around. If you're viewing this in a replay later or you're viewing on YouTube, definitely feel free to post a comment or question as well. Mohit and or I will be happy to answer. Mohit, thank you for being the first guest, the first interviewee. This has been great. .commie says thank you. I'm sure other folks that are watching say thank you as well. You've been great. Enjoy the rest of your Friday, and we cannot wait to see what you're going to be doing next at Particle and then also on Instagram, man.
Thank you. Thank you so much for your time. Thank you for hosting me. And thank you for everyone who attended this stream.
It's great. All right. Have a great rest of the day, everybody. Thanks. Bye.
Bye.